second part of the stat stuff. All right, I'm going to get my little pink sheet because that's going to be useful for me. I think this is the part that we're going to be using here.
Did you start it?
So, if the mean age of all students at EHS was 16.2 years old with a standard deviation of 0.7, determine the following. What interval captures 99.7% of all ages? Now remember, our bell curve is based off of the 68, 95, 99.7 rule. So if they give you any of these numbers, okay? Okay. So whenever you see one of these three rules, you're using your straight bell curve right there. So let's draw a bell curve. All right. There's my mean. If they tell me that the mean is 16.2, that's what I'm putting right there. Then I draw my 3 lines on the right and 3 lines on the left. And I'm going to label those lines by either adding the standard deviation or subtracting it. So if I do the right side, 16.7 plus 0.7. Let's type in the right number. 16.7 plus 0.7 gives me 17.4. Plus another 0.7 gives me 18.1. And plus another 0.7 gives me 18.8. Now I'm going to do the other side. 16.2 minus 0.7 is 15.5. Minus another 0.7 is 14.8. And minus another 0.7 is 14.1. Now, in the previous stats video, I went over the percentages, but real quick, we have 34, we have 13.5, 13.5, 2.35, 2.35, and 0.15 for these last ones. So, 99.7% is going to be from here to here. So from the very last marker to the very first marker. So 14.1 to 18.8. I need to add up all of those numbers in here. So 2.35 plus 13.5 plus 34 plus 34 plus 13.5 plus 2.35. That will give me the 99.7%. So what interval? It would be from 14.1, bless you, to 18.8 years old. It's wrong? Did I do it wrong? What did I do?
16.9 for that interval.
Did I do it wrong? 16.9 right here. You're right. And then what?
And then it's
17.6 and 18.3. So this is 18.3, not 18.8. Thank you. Okay. So questions on that?
No.
All right. What is the probability that a student at EHS is older than 17.6? Is 17.6 one of my numbers here?
No.
Yes.
Yes.
Right there. Older than would be to the right, correct? Because all the numbers to the left are less than.
Yeah.
So I just need to add 2.35 plus 0.15. And what does that get me? 2.5%. If they asked for less than 17.6, I'd be adding all the numbers less than, or to the left of. In fact, they asked me that in the next question. What's the probability that a student is younger than 17.6%? Now, I can do this 2 different ways. I can add up all the numbers to the left of 17.6, or if I know that's how much is older, how can I find younger? 100% minus the percent that's older. And that gives me 97.5%. And again, you'd get 97.5 if you added up the 13.5, 34, 34, 13.5, 2.35, and 0.15. Okay? What is the probability that a student is younger than 15.5 years old? So here's 15.5 years old. Younger would be to the left, so I need to add 13.5 plus 2.35 plus 0.15. And that gives me, I believe, 16% is the probability that a student is younger than 15.5 years. What is the probability that a student is 18 years old or older? Is 18 one of my markers here? No. As soon as I get to something that's not on there, I have to use my z-score and my z-table. So we're going to calculate the z-score for 18. So that would be 18 minus the mean. What was the mean? 16.2 divided by the standard deviation, which is 0.7. So 18 minus 16.2 divided by 0.7 gives me 2.571. How many digits do I need for my z-score table? I need 2 digits past the decimal, so that's going to be 5.7. If this next digit caused me to round it, I do need to round that to a 5.8 in that case. So let me grab my z-score table. 2.57. 2.5. Yes, you will be given this on the test. You don't need to memorize all of these numbers. 2.5. Where's the 7 column? It's over here. 0.9949. So 0.9949. So what is that number representing? The number or the percent of students that would be less than 18. If they're wanting to know older, how do I figure this out? Because this is 99.49%. I have to subtract it from 100%. So if I subtract that, 100 minus 99.49, I get 0.51%. Okay? Or if you wanted that as decimal, if it was in decimal form on the test, it would be 0.0051. What is the probability that a student is between 15 and 17? As soon as you have between, find the z-score, do bigger minus smaller. That's your between. So let's start off with the z-score of 17, so that way I can do the bigger one first. So I'm going to use the same thing I did up here, 17 minus 16.2, all divided by 0.7. So 17 minus 16.2 divided by 0.7 gives me 1.14. Let's go to the z-score table. 1.14, 1.1, 0, 1, 2, 3, 4 is 0.8729. Or in other words, 87.29%. And now let me find the z-score for 15. So 15 minus 16.2 divided by 0.7. And this one's going to be negative. I get negative 1.71. Let's go to our z-score table. Negative 1.71 is 0.0436. Or in other words, 4.36%. So what do? Take the bigger one, subtract the smaller one. So 87.29% minus 4.36% will give me my answer. 87.29 minus 4.36, 82.93%. Now I don't know on the test if it'll be given in percent form or decimal form. If it's decimal form, that's 0.8293. Okay, any questions? The time that students take to complete a test is 97.4 minutes with a standard deviation of 15 minutes. A random sample of 35 student times is chosen. What interval captures 95% of the means for the 35 times? Now, you notice it says means and it doesn't say anything about being normal. Therefore, we can't use our bell curve. Remember, we have our formulas split up into proportions and means. We're going to be looking down here. Okay? Now, 95%, if you remember back on the previous page, 95% is 2 standard deviations above the mean and 2 standard deviations below the mean. Do you remember that?
Yeah.
So, I'm going to take the mean, which is 97.4, and I'm going to subtract 2 standard deviations. That'll get me the left side, or the lower boundary of this interval. Then I'm also going to take 97.4 and I'm going to add 2 standard deviations, and that will give me the right side, or the upper boundary of the 95%. So, 97.4 minus 2 times 15 gives me 67.4. Hang on, I did this wrong. See? You guys got me all distracted. Okay, I can't do that because that's the standard deviation of the original population. I need to do the standard deviation of the means. So before I can do this is all correct except for the 15 part. I have to use one of my formulas there. So let's get rid of that guy. I need to find my mean standard deviation. Okay? Standard deviation of the means is standard deviation of the whole thing, which is the 15, over the square root of n. What is n in this case? This is the standard deviation I need to use. 15 divided by the square root of 35. We'll call that 2.535. 3 digits sounds good. That's what I'm going to put in here. 2.535 and 2.535. All right, now we're back on track. So 97.4 minus 2 times 2.535 gives me 92.33. And if I go back and change that minus to a plus, I get 102.47. So, what interval captures 95% of the means? It would be from 92.33 to 102.47 minutes. Okay. All right. What is the probability that a random sample mean has a time of more than 100 minutes? Well, I'm going to need to find my z-score. So I'm going to use z equals the mean, which is, I'm sorry, not the mean, the 100 minutes minus the mean of the whole thing, which is 97.4, divided by the standard deviation. Now we're still using this 2.535, the standard deviation that I found right there. That gives me what for a z-score? 100 minus 97.4 divided by 2.535, 1.03. Now, since I just found a z-score, let's go back to our z-score table. 1.03, 1.00123 is 84.85%. 84.85%. Now that is the percent that would get less than 100 minutes, correct? So to find more than 100 minutes, I have to subtract this from 100%. So 100% minus that. And that gives me 15.15%. Or if they have it in decimal form, it would be 0.1515. Okay. Next question is very similar. What is the probability that a random sample mean has a time less than 90 minutes? So same idea. I'm going to find the z-score for 90. So 90 minus 97.4 divided by 2.535. 90 minus 97.4 divided by 2.535 is Negative 2.919 would round off to 2.92. So let's go to the table. Negative 2.92 is 0.0018. 0.0018. So as a percentage, do I leave it like this or do I subtract it from 100?
Leave it like that.
Leave it like that. Why?
It's less than.
Because it's less than. So this is 0.18%. Or if they ask for it in decimal form, it would just be the 0.0018. All right, what is the probability that a random sample has a mean time between 90 and 100? Well, I already found those, right? 90 and 100. Except that when I do the between, I need to know less than 90 and less than 100, and then I'm going to subtract them. Well, less than 90 I know is 0.18%. 100, this was more than 100, wasn't it? What was less than 100? It was 84.85%. That's what I need to subtract. So 84.85 minus 0.18 gives me 84.67%, or if it's in decimal form, it would be 0.8467. Okay? In a random sample of 100 teenagers in California, it was determined that the mean age they got their first driver's license was 16.9 years old. That's good to know. That right there is X bar, with a standard deviation of 0.25. That right there is sigma. Find a 90% confidence interval. That means I need to find Z sub 90. And from my sheet, I know that that Z sub 90 is 1.645. For the mean age of teenagers when they got their first driver's license. Let's see, I think I've identified everything except the 100. That is my N value, correct?
Yes.
So, we're dealing with means here, so that's the population standard deviation. I need to find the standard deviation of the means. So in other words, sigma sub X bar. From my sheet over here, sigma sub X bar is equal to the standard deviation of the whole thing, the 0.25, over the square root of 100. And when I do that, 0.25 divided by square root of 100, which we know is 10, I get 0.025. So, how am I going to find this? Well, when I'm looking for a 90% confidence interval, I need to use this right here. So I'm going to take 16.9, which is my original X bar, 16.9. I am going to subtract my Z sub 90 times the standard deviation.
Is that the new one or the old one?
The new standard deviation. And then to find the other boundary, I'm going to do the same thing, except I'm going to add 1.645 times the new standard deviation. Now, if you remember, was it earlier on this page or was it up here, how we did -2 and +2 because we knew that 95% was 2 in either direction, right? When we have 90% confidence interval, we don't use 2, we use whatever the decimal is that corresponds with that confidence interval. So it's the same process there. So I'm going to get those two values. So 16.9 minus 1.645 times 0.025. And I get a really long decimal, 16.859, we'll call it 86. Okay, and then if I go and change that minus to a plus, I get 16.94. So what is my interval? My interval is between, let's make that a capital like I'm writing a sentence, between 16.86 and 16 and not 0.94 years old would be my answer. Okay? All right. All right. It bothers me that this is on 2 pages. Suppose that 52% of all teachers at EHS, I'm going to call that mu sub p hat, which also equals mu, as our, I think it's supposed to say up there, mu sub p hat is equal to the proportion of the whole thing right there, equals p equals 0.52. 52% of all teachers attend at least one sporting event each month. Eliza plans to survey a random sample of 40 teachers. What proportion of the teachers in her sample are likely to have attended a sporting event in the last month? Notice it's not talking about a confidence interval. It's just saying likely. That means we're going to do the +2 standard deviations and the -2 standard deviations. So, got to find some things. First thing I got to do is I have to see, does this indeed, is it going to work out? I need to figure out the whole, remember the NP has to be greater than or equal to 10. And n times 1 minus p also has to be greater than or equal to 10. Because if those two things are true, then it is approximately normal, and I can just use my 2 standard deviations. So, what is my n value? N equals 40. So, 40 times my p value, I'll write it up here from the previous page, is 0.52. 40 times 0.52 has to be greater than or equal to 10. And 40 times 0.52 is 20.8. Yes, that's greater than or equal to 10, so we're good there. Now let's try 40 times 1 minus 0.52. That also has to be greater than or equal to 10. So 40 times 1 minus 0.52, 19.2, and that's also greater than 10. So we can use all of our information. So I need to find the standard deviation of the sample proportions. Again, that's a formula off my sheet. That's going to be equal to the square root of p, which is 0.52, times 1 minus p, divided by n, which is 40. So, 0.52 times 1 minus 0.52 is that, divided by 40, and then taking the square root of that answer, that equals 0.0789, let's call it 790, or 0.79. Oops. Okay, so likely interval. Likely interval, that means I'm going to take the mean, which is my 0.52, and I'm going to subtract 2 standard deviations, and I'm going to add 2 standard deviations. That's what we do when we have likely or reasonable or any of those words right there. So 0.52 minus 2 times this should be 0.79. Goodness, I'm messing them all up. And 0.79. And I get 0.362. And arrowing back and changing that minus to a plus gives me 0.678. Oops. So I can go ahead and change those to percents. It should say between 36.2% and 67.8% would be my answer there. Okay. Miranda is a biologist who wants to know more about frogs in a certain region. Given that the mean length of frogs in the region is 7.35 centimeters with a standard deviation of 0.71, what size sample should she take to ensure, I think that should be ensure, a 99% confidence level? Now, there's a key piece of information that we forgot to put on this question, and that is that the margin of error is 0.2 centimeters. Now, you cannot solve the problem without that piece of information. So, margin of error. Let's see, where do we see margin of error? We see it here. We see it here. See those? And then we get our N formulas. So which one do you think we're using? Are we using one that has to deal with proportions or one that has to do with means? What do you think we're looking at? Mean length?
Yeah.
I think we're doing the means. So, so our sample size is going to equal Z sub C. What is our C value here? 99 times the standard deviation divided by the common error, or the margin of error, sorry. And we're going to square that. So, Z sub 99 from that sheet was 2.576 times the standard deviation. What's the standard deviation? 0.71. Divide that by the margin of error, which is 0.2. And then we're going to take that whole thing and square it. So, let's see. 2.576 times 0.71 gives me that, divided by 0.2, and then I'm going to square it, and I get 83.627, but this is a sample size, right? What size sample? Can he test 83.6 frogs?
Oh.
How many frogs does he need to test?
84.
84 frogs would be the sample size. Okay. All right. Last problem here. We don't need to do any calculations. We do need to identify, is it a survey, an observational study, or an experiment, and then identify the appropriate information. So, first one, to determine a connection between artificial sweeteners and kidney problems. 100 people were asked how much artificial sweeteners they consumed in a week and were tested by their doctors for proper kidney function. Is this a survey? No. Way too much going on. Is it an observational study or an experiment? Here's my question. Is there a treatment or not? There's no treatment, which makes it an observational study. So, for an observational study, we need to identify the factor. In other words, what is it that they are looking at? They are looking at the amount of sweetener consumed. We need the characteristic of interest. What's the characteristic of interest? Kidney. I'm going to say effect on kidneys. On kidneys. Okay? All right, B. A sample of 50 EHS students was asked who their favorite music artist is. Survey. And for a survey, what do I need to identify? The characteristic of interest. What's the characteristic of interest? That would be favorite music artist. All right. A group of 25 hospital patients were played soft music as they fell asleep each night, while another 25 patients slept in silence. Each night, nurses recorded how many hours the patients slept. That's hopefully clear. It's not a survey. Is there a treatment? Yes. What is that treatment?
Soft music.
So the treatment is soft music. Oops. Can't spell music.
Is it an experiment?
That makes it an experiment. As soon as there's a treatment, there is an experiment. So there's the treatment. What's the characteristic of interest?
Hours.
Hours of sleep. What's the treatment group? The patients with music. And the control group would be the patients with silence. Okay? All right, last one. To determine the effectiveness of a new drug, 60 patients were randomly chosen who had a certain medical condition. 20 patients were administered 100 milligrams of the drug. 20 patients were administered 50 milligrams of the drug. 20 patients were given a fake pill with 0 milligrams of the drug. At the end of 6 months, the patients were tested to determine the effect of the drug. What have we got here? Experiment. Okay, what is the characteristic of interest?
Effective drug.
The effect of the drug after 6 months.
Do we gotta put that too?
It's multiple choice. So you won't have to write anything except A, B, C, or D. All right. What is the treatment group? There are actually treatment groups. There are 2 treatment groups in this one. One treatment group is the 20 people with 100 milligrams, right? Another treatment group is the 20 people with 50 milligrams. What is the control group? Control group is 20 people with fake pill. Do you remember what a fake pill is called?
Placebo.
A placebo. What else do I need? Treatment. What is the treatment? Either 50 milligrams or 100 milligrams of the medicine. Okay? Happy studying!